Good day, my name is Janeka Thomas, and today we'll be talking about glass. Today's objectives are as follows. Describe how glass fractures, different types of glass, densities of glass, and how to analyze glass fractures. To first start off, you must ask what is glass. So, glass is a solid, but it is an amorphous solid, and it has an irregular atomic structure. So now that you know what glass is made of, next will be density. The formula for density is D equals M divided by V. M being mass and V being volume. To get density, you divide mass in grams by volume in milliliters. These are the common examples of densities in glass. Glass fractures. Impacted glass compress on the side that it is hit, and it stretches out on the opposite side. When the glass is hit, it forms concentric and radial fractures. Concentric is circular and radial is outward.
Alright, so first I'm going to put on my gloves. Now that I have my gloves on, I will take my nail and a hammer and hit it right in the middle. Make sure to keep it steady.
Right, now that the glass is cracked, you can see that there is radial fractures going outwards and a bit concentric if you look very closely. The glass is fractured very badly, as you can see, because I hit very hard. And that is the demonstration. There are many things that can impact a fracture, such as bullets. As a bullet passes through glass, it pushes out a cone-shaped piece of glass. Whenever a bullet impacts a glass, the entrance hole is smaller than the exit hole. Bullets helps with locating shooters because whenever a shooter shoots from a certain angle, it always becomes the opposite. Such as if you shoot from the right angle, the bullet will come out. Which fracture came first? As you can see, this fracture has the longest radial lines. So it would be considered the first one. Because when you have other fractures, those other fractures goes to meet that line. Next, we'll look for the second fracture. We'll look to see which one connects closer to the first one. Between both of these, it will be this one. This will be fracture B because its radial lines are connecting closer to radial lines of A. And you can see that when it comes, it continues. It just meets fracture A. So this will be fracture B. Lastly, this will be C because its line meets it too, but it doesn't. Some tips to help with the challenge is to get 2 hammers. Sometimes that works. Also, you can try put in all your force into it, in all your anger, rage to hit the glass, make sure it will break. Arrives while breaking the glass and doing the project were the glass itself. The glass was very thick, so I had to use 2 types of hammers. Originally, I used a small hammer, and then over time, I went on to use a bigger hammer. In conclusion, glass evidence is important to forensic scientists. Glass can be analyzed by comparing the refractive index of the sample to the possible source. This especially helped with the case of Tracy Tomiko. The case that we researched was about Tracy Tomiko. She went on her daily run and she never came home. Her death was a mystery. Tiny pieces of evidence told police that Tracy was hit by a car. The trace evidence that was left behind had pieces of glass and a piece of plastic in it too. The police used that as a key to unlocking the mystery. After figuring out the plastic came from a Ford Tempo, they connected it with a car that was missing a plastic. Later on, the suspect confessed.
My name is Maisha Jean, and my part in the glass project is doing the submersion method. The submersion method is used when small fragments of glass found at a crime scene are very small. It involves submerging a sample of glass fragments into various liquids with known refractive index. In any case, if the refractive index of the glass does not match that of the liquid, you can estimate the refractive index of the glass based on how visible it appears in the different liquids. The materials I have with me today are water, 70% alcohol, and vegetable oil. I also have 3 test tubes, 3 pieces of glass from a window, and tweezers. The first thing you want to do is pour a good amount of liquid into your test tube. I'm going to start with water. Next, take your tweezers and grab the piece of glass and drop it into the liquid. As you can see, the glass is still visible. Now you want to do the same thing with your second liquid. I'm doing with alcohol. Pick up your glass, drop it in. In this liquid, the glass seems to be disappearing a little bit. And for the third solution, I'm using vegetable oil. Do the same thing like the first ones. Take a piece of glass, drop it into the oil. The glass appears less visible in the oil because they both have the same refractive index.
Hello, good day. My name is Eloise Commodore and I am a part of the group that will be talking about glass. My part is to introduce it. So glass is found everywhere. It could be found in windows, cabinet doors, glass doors, sliding doors. In crime scenes, although it's very small and can be very hard to identify and individualize, it is very helpful in crime scenes. It can be found on people's hair, their clothing, their shoes, and when examined, it can help the forensics team to identify the suspects and piece together a crime scene. Glass evidence is usually found in robberies or where there is an altercation. Let's say there's a fight and they try to break the glass over the person's head. There can also be, like from a car accident, if someone tries to break into your car, they could break the windshield, and glass could also be found in those places. There are a lot of different types of glass, a lot of different textures, and that will all play into how it helps the forensic team to identify suspects using the glass fragments, such as the density, the thickness, and the index, all help forensic scientists to identify glass and individualize it in order to help solve a crime. Here are some tips on glass evidence. So when collecting glass evidence, you do not want to store them together in something that can break, something that moves around a lot, so they don't hit together and break, making it more difficult for you to identify and put together. You also don't want to put it in cloth because it can get stuck in the cloth and make it also more difficult for you to identify and classify. Another tip for glass evidence is make sure that you check the suspect's clothing properly, because glass evidence is very small and the fragments can be very easily lost, and usually if there is glass evidence, it can be lost in 24 hours. So if you have a suspect, make sure that you check for broken pieces of glass, no matter how small they are, carefully.